Hey everyone, my name is Morgan Hunt. I'm a senior Flutter engineer and I've been coding in Flutter for over 2 years now. Today we're going to be talking about the build runner, what it is, how it works, and we'll be creating our own build runner package. So let's go ahead and get started. So what is the build runner? The build runner is basically a code generator that takes an input from our code and gives us a generated output that we'll be able to use within our code. So how does it work? The build runner will look for files that are indicated usually by an annotation saying that it needs code generation, for example, JSON serializable. When this file is found, it will take all of the information like the file name, the annotation, and the element that's annotated, like this class here, and give it to the package that is using the build runner. This package will then take all of that information and make some generated code for us and put it inside of a generated file that we'll be able to use inside of our project. This can all be done by running a simple command in our terminal. This is the build runner build command. There are two variations of this command. There is the build and the watch commands. Build will run the build runner once, while watch will listen to our files, and if we make any changes, it'll update the generated code accordingly. This flag, the delete conflicting outputs, basically tells build runner to ignore any old generated code and replace it with the new generated code without asking any questions. So when we run this command, what happens is the build runner will analyze our project. It'll start at the very top, A through Z, go through all of our files, analyze each and every one looking for specific annotations. It will run through our files for every single builder that we depend on. So if we have a big project, it could take a while to go through all of those files. So it's a good idea to isolate all of the files that require code generation into one location. Then the build runner only will check those files and it'll speed up so that way it doesn't have to check through all of our files and all of the folders. That can be achieved by configuring our build.yaml file. So for example, if we just wanted to access only these files or wanted the build runner to only check these files, we can go inside of our build.yaml file and under the generate for key and provide a pattern. This pattern is called a glob pattern, and you can look up the syntax and play with it to get exactly what you want. But basically this will tell the build runner to only look for files within the lib folder. And by doing so, it'll ignore all of these other folders. It won't even touch them. Next, if we wanted to fine-tune our included folders a little bit more, we can actually exclude them if we want to. So for example, if we wanted to ignore all of our main files, these ones right here, we could add an exclude key with another pattern saying like these are the files that we want to exclude, and it won't touch those. It'll only read these 4 files. Cool. So, but why should you use build runner in your projects? Well, let's look at an example. This is a basic serialization to convert to and from JSON. JSON serializable makes it so that it will automate this whole process. So instead of writing code like this, you would write something like this. So it reduces the amount of code and it also will do all of the checks for you. When I say do all these checks, let's look at the previous code again and look at what things I'm referring to. There are a lot of things that could go wrong inside of this, or things that you have to serialize your class properly. For example, you have to make sure that the keys are correct, that you're casting it to the right type, making it nullable when necessary, calling to JSON if the object requires. And don't forget to add that new property that you added to the class to both methods. It can get kind of hairy if you're not careful. JSON serializable will automate this whole thing for you and do all of these checks and keep your serialization up to date as long as you run the build runner. Cool, so I've got your attention. What are some packages that you could use? Well, we've already talked about JSON serializable. A package that I've created is called enum assist, and this will help you with extending your enums and make them more usable within your projects. Another one is freeze. This one's pretty popular. Makes it easier to create unions. Very, very useful stuff. There's another package that I'm creating called ice. It's a freezed alternative. It is very similar to freezed. It just opens up a little bit of the syntax and features. Cool. So can you create your own? let's go ahead and get started. The first thing that you need to do when building your own build runner package is you need to find a problem or find something that you need to automate. In this case, what we're going to be fixing is field keys for maps and serialization. I want a central location for all of my keys, and so that's what we're going to do here. So let's first start off by creating a class and giving it a field, and then annotating it with some sort of annotation. And the generated code should look something like this, where we get the key, which is the name of the field, and we can access this generated code possibly through a static variable within our class. And then we would be able to use this in our code like so. But what if this value here needs to be in a different format, like a snake case, for example? Well, we could change this, and in order to get this expected value, we would need to update this value to be snake case. And that value is dependent on the name of the field. So I guess we could change that to snake case too, but that's not Dart convention, and that doesn't work very well. So let's change that back. And I guess one possible solution is that we create a new annotation specifically for the fields to give that field a specific key. So it could look something like that. Yeah, I think that'll work pretty good. So now we have our concept. Now we can start creating our code generation package. So using Very Good CLI, I've created this package. And now we got to add our dependencies. So inside of our pubspec.yaml, we're going to add our dependency, and the only one that we're going to add is meta. So let's jump over into our annotations file to start creating our annotations. This is what's here right now, so let's go ahead and remove that and create our annotation, which just is a regular class. Notice here that we have a const or a constant constructor. It's necessary that our annotations are always constant. We're going to use an annotation from the meta dependency so that we can say what exactly this annotation is going to be used for. We're expecting this field's annotation or this field's class to only be used on class elements. And so we're going to specify that within this target annotation. So let's add the class for our target and make sure that we import that. Notice that we don't have any parameters here. So instantiating this class is kind of redundant. We could probably do it by just creating a global variable and instantiating it like this. Next, we need to create this annotation for our field, for the property, to give it a specific key. So we've created our annotations. Now we just need to export those in this project. We want to export our fields annotation and our field annotation, but we don't want to export this. So we are just going to name them with our export right here, and our annotations package is done. One thing to note, it's important that we have our annotations and our generator packages separated. Reason being is because our annotations package, as you can see, has very little dependencies. It has almost nothing. It's specific only to our generator package, which will have a lot more dependencies that may conflict with other dependencies, such as Flutter. You can't use build runner packages, or you can't depend on build runner packages within Flutter. They have to be used as a dev dependency. Let's go ahead and jump over into our generator package. First thing to start off is this package name right now currently is class fields generator. It's not written, but by convention, you can omit the generator name and just leave this as class fields, because it's implied that it is the generator. That is the purpose of this. So you can leave that off. All right, so let's go ahead and add our dependencies. Our first one is going to be the analyzer package. This is a package that helps us know the elements and their properties and their values, etc. We get all of the details of the code that is our input. Next, we have our build package, and this is like the core for Build Runner. And then we have our annotations package that we just created. Next, we have meta, and this is to help the analyzer. And SourceGen. This is a utilities package that will help us generate the code. All right, so let's start configuring our build runner. And we can do that by creating the build.yaml file. Inside of this, we're going to start by creating a key builders and providing an object of class fields. Now, this class fields is the name of the build runner, and typically that's also the name of the package. Next, we need to provide an import. This is going to be the entry point for the build runner. This is how the build runner is going to access our code to be able to generate code. Next, we need to provide the factory or the function that the build runner is going to use to access our code. And then the build extension. This is going to take the .dart extension and replace it with classfields.g.part. Now, we are configuring our build runner to be a shared part builder, which just means that our project, along with any other project that uses shared part builder, is going to be generated into one file instead of creating multiple different files. I'll show you how we can configure a part builder in a little bit. Next is auto apply dependence. If somebody depends on this project, then it will automatically be added to the list of build runners that they are running. So that way they don't have to go into the build.yaml and enable it manually. Next is build to cache. Instead of saving the generated file directly inside of your library, it's going to save it within our Dart tool folder and be cached there. Next, we're going to be adding the applies builder, and we're going to be adding the SourceGen combining builder, which will take all of our cached files and build them into the .g.dart file. If we were configuring a part builder, there are a few differences. The first one is this extension. This is going to replace the .dart extension. And here's an example of what that could look like. Next is build to source. This just means that it's going to be saved within your library or within your project directly, rather than the Dart tool folder. And because we're not depending on any other builders, we can omit this applies builder. All right, so we've configured our builder. Now we just need to make sure that we have the right path for our import. So here we've said that it's located at the classfields.dart file, and currently it is not named that. So we are going to just rename this file. Jumping into the classfields.dart file, this is where our factory or our function for the entry point of the build runner is going to live. So let's go ahead and get rid of this, and let's create our build runner entry point. And it has a return type of builder, and this comes from the build dependency. We are going to be returning a shared part builder, and this comes from the SourceGen package. Shared part builder accepts two arguments, or requires two arguments. One is the generator, which we'll create here in a second. And the second one is the ID for the builder that we're creating. This should be the name of our builder that we've configured within our build.yaml file. This will also be appended onto the extension of the file that gets generated right here. If we were creating a part builder, so if we wanted to create a different file other than the .g.dart file, this is how we would configure it, with the main difference being this fields.dart extension. This should match the same extension that we have inside of our build.yaml file. One thing to point out is this builder options. These are the configurations that anybody who depends on this project can configure within the build.yaml file. So that's where these values come from. The options has the key value, and it's string. The keys are strings and the values are dynamic. And you can access those within the builder options, so that way you can configure your builder based on those configurations within the build.yaml file. So let's go ahead and create our generator. And we're going to start that by creating this class that extends generate for annotation. Generate for annotation comes from the SourceGen package. This class will be called upon for every element that is annotated with the field annotation, which comes from our package that we just created. We're going to override one method, which is the generate for annotated element. And it provides us with 3 parameters. These parameters come from the build package. Referencing our concept, first we have the element, and that is, for this, our class that is annotated. It'll give us all of the constructors, the name of the class, the fields, etc. Next, we have the annotation. And this, the constant reader, is a way that we can get the fields data. So if we had any fields or any arguments that were accepted inside the fields class, we could read those with this annotation. Next, we have the build step. Build step is the way that our builder can communicate with anything outside of the generator. So this means that we can look into the file that is being generated for. We can also create the generated file using build step. It's important to note that our generator should be very independent. It should not depend on anything that we don't already know the value to. All right, so moving on. Our element, we have specified that we only want to be using it for a class, but it's not stopping anybody from using it incorrectly. So we're just going to make sure that we do a check to make sure that the element is actually a class element. We're going to throw this error. This error is specific to generators. You should be using this throughout your generator to throw exceptions. It will print directly to the console and have everything formatted correctly. It accepts the reason as well as the element that is causing the problem. Our next achievement is to parse our element. So we're going to create a class, create a factory to parse this element. So we created the file, now we're creating the class. And the properties that we need for the class in order to successfully generate our code is namely the name of the class and the fields. We don't have the fields class yet, so let's go ahead and create a file and then create that class. The field class, we really need to just know the name of the field as well as the key, which could be the name of the field, but it also could be the annotation. So here we have the name, now we have the key. The annotation is not required for the field, so we should not be expecting that. So I'm going to change that to a nullable string and then just declare or assign the key value for our field class with the key that is provided in the constructor. If not, we're going to use the name. Moving back to our class, we're going to finish up parsing it. So we're going to create our factory and we're going to import the analyzer because that's where the class element comes from. And now we're going to get the name from the element, and that's element.og's. That is a lot of data points, a lot of properties. I don't know what exactly we should use. I mean, we could probably guess as to what we need to use, but like I said, there's a lot of data in here. And so I'm not quite sure which one it is, or sometimes there's multiples of the same thing. Like we have name and display name. Which one should we be using? We don't know. So what we can do is we can print out the element, but that is not always the right way to do things. Just because, again, there's so much information, and imagine running the build runner every time just to figure out a new data point. There's got to be an easier way to do this. Thankfully, there is. I've had to create one because I've done this many times. So what we're going to do is we're going to jump over into our pubspec.yaml and add a new dependency. We're going to add the generator test dependency. We're going to be leveraging our tests to be able to debug our project to find out what the elements properties are and what we need to use in order to successfully parse our class. All right, so let's go ahead and create our class, or create our file for our test. Let's create our test. And now we're going to use our generator test, or our success generator. And we're going to pull that in from the generator test dependency. The from builder accepts 2 arguments. The first one is the name of the file that we are going to be referencing within our project to generate code for. And then the next is the entry point for the builder. So let's just make sure to import that. This next part is the compare with fixture, which basically is saying that we don't have any output code that we want to compare against. So we are just going to test to see if this is generated completely. We're not ready to test any outputs. We just want to figure out what is in our element. Our final piece is that we just need to write a sync and await for our tests. So that way we can add a breakpoint and debug our project. Before we debug our project, we just have to create our example file, add an example class, annotate it with our fields annotation, and we should be good. So we have our test now. Let's go ahead and add our breakpoint, and let's debug our project. It'll run, and there, we've hit the breakpoint. And now we can look at all of the data that we have. Now, this is only a fraction of what the actual data is because it's so long I couldn't fit it on the screen. So we can see here that we have name, which is what we're looking for. And we have the fields, and here we can see all of the fields values. So now we know exactly what we need, where we can get it, and then we can parse our elements. So let's go ahead and resume our parsing. So let's go ahead and get rid of that. And now we can get the name from the element.name. And now we're going to get the fields. Quick note, it's really beneficial to use synchronous generators within your generator packages because synchronous generators are going to create a lazy iterable, which means that we are going to be able to create this field. We're going to be able to create a list of fields, but they're only going to be created or instantiated when we call on them. So let's go ahead and loop through all of the fields, and we're going to parse it from the fields class. Now, we also need to do a couple of conditional checks. We need to make sure that the field is actually a field. And we can do that by checking to make sure that it's not a synthetic field. If it's synthetic, that just means that we have written a getter inside of our class or inside of our object. And then the next one that we need to check for is if it's static. If it's a static variable, static field, we want to ignore that too. Cool. Lastly, we need to return the class with the name and fields, and we have successfully parsed our class. Let's jump over to our field really quick, so that way we can parse this. Let's create our factory, import our analyzer, and get the name of the element. And then we're going to get the annotation from the field. We can do that by leveraging SourceGen and creating a type checker. This accepts our annotation as an argument. So we're going to write in our annotation, make sure to import that. In this case, our class that we are creating happens to be the same name as our annotation. So we're just going to name our import so that way they don't get confused. Now that we have the type checker, we can now look for any annotations of the element that are of the type field. So we're going to do the field annotation checker dot first annotation of the element, which will return the annotation if it exists. We're going to do a quick check to make sure that it's not null, and we're going to provide it into a constant reader. The constant reader makes it so that we can read the data from the annotation. So we know that in the field class, we have a property named key, and that is a type string. So in order to get the key for the parse, we need to use the reader.read, providing the property's name, which is key, and casting it as a type string to read that value. Lastly, we just need to return the field with its name and its key. And now we have successfully parsed our elements. Now we can move on to writing our generator and the code. We'll do that by creating a template and providing the subject or the class and calling generate. So creating our generator file or our template file, we're going to create a class for the template. which accepts a class as the argument, and write one function that will generate our code for us. Now there is a helpful package. This happens to be pretty verbose, and it's nothing that you can achieve on your own, but I prefer to write things on my own. And so just know that this is available. So for now, we're going to be using a string buffer. A string buffer is just very efficient at concatenating strings, just plugging them all together. And yeah, so use it, it's efficient. So let's go ahead and check out our generated code. So going back to our concept, this is the generated code that we are trying to generate. We just need to configure this. It's not quite configured to be generated yet. So first off is this class, the class name. If it can be private for generated code, if it can be private, then make it private. Try to make it private for as long as possible until you can't anymore, where it needs to be used outside of your generated code or outside of the part file. Another convention is the $. We'd use the $sign in front of the class name to indicate that this is generated code and it should only be consumed by the generator. If it's supposed to be consumed by a developer or a human, leave the $sign off. So because this is going to only be used within the part file, we're going to add the $sign in private. Now, what if there are multiple classes that are annotated within a single file? We have to have some way to indicate that this generated code is for a specific class. So what we're going to do is we're going to prepend the class's name to our generated code. So let's take this and use it as reference while we are generating or while we're writing our template. First thing that we're going to do is write our class name. So we're just going to create a variable. And next we need to create our fields. And we're going to map through all of the fields and write them like so. Make sure to write all the syntax, the quotation marks, the semicolon, because you're writing Dart code within a string. Don't worry, if you miss something, the builder is very, very good at its job at telling you when something's wrong, because your code is either not going to run or it's not going to be formatted correctly and it's just going to look terrible. And so it's really good at providing feedback if you missed something. All right, so now we can start on our actual template. So let's start by writing out the class. And now we need to add the brackets. And now let's write the constructor. And you might be tempted to add this space at the beginning because it is indented, but it's not necessary because the build runner will actually format your code for you. So you can leave that off and you'll be totally fine. Next, we need to write our fields. And we can do that with separating by a line break. And that's it. Like, we've created our generated code. However, this is kind of hard to read. And because it is so simple, we could probably get away with refactoring it into a multi-string. And this is a lot easier to read. It looks really nice and it's still efficient. Congratulations. You've created your first project. You've created your first build runner. So now the next steps to this are you still have to write tests. You still need to make sure that everything is working properly. Add new features if you want to. There's a lot more that you can do. Unfortunately, I don't have enough time to go over testing, but that will be something that I release in the future. So just stay pendant. I'm on Twitter, and that's probably where I'll post it. So just be on the lookout. And thank you for your time.